Good morning. This is Miss Billerbeck, and we're going to talk about 12.3 cones. So a circular cone, or just a cone, is a solid figure that has a circular base and a vertex that is not on the plane of the base. Well, what does that mean? So that means that this vertex right here and right here are in a different plane than this circular base right here and right here. Now these are drawings of an oblique circular cone. So an oblique circular cone means that the height is not intersecting the center of the base at a right angle. Okay, when we do have that special situation where the height intersects the center of the circle of the circular base, then that is a right circular cone. So the height here is at making a right angle with the radius here. And then we have a new letter here, which is L. So this new letter here is for the lateral edge of the cone. Just like we have a lateral edge of a pyramid, this is the lateral edge of a cone. And so L stands for the lateral length of that cone. So cones actually don't have edges because they're circular. So it's just the length of that cone as we see it when it looks like it's an edge, although circles never have edges, do they? All right, let's go look at more about cones using some manipulatives. So let's share. There we go. Okay, so if we have this, we have a cone here, and let's just take a look at if we press this, see what happens. Now this happens to be the lateral face of the cone, okay, or lateral surface, or your book likes to call it a curved surface area. Okay, so if we see that we have the circumference of a circle is 2 pi r, and we have a lateral edge here of, or a lateral length of L. So if we look at the area of this, it looks like it's going to be the length of this here is 2 pi r times L would be our surface area of this lateral surface area of the cone. All right, so that's one aspect of a cone. Now let's look at the second aspect. Okay, so we actually do have more than just a lateral surface area. Look at that. We have a base as well as that lateral surface area. So we have to account when we calculate total surface area that we have to have the lateral surface area and the area of the circle, which is its base. So let's look at that formula. Let's see. So the area of the surface area, the formula for our cone is pi r squared, which is the area of the circular base, plus pi rs. And so for this, instead of using L, they're using S for this. Okay, so we just need to be flexible sometimes with the letters that others use to depict the formulas. So in your book, instead of using S, they use L. So that would be the total surface area versus this one is just the lateral surface area. There's no base. Okay, so now let's look at volume. Okay, the formula for the volume is 1/3 pi r squared h. So that looks familiar. It should look familiar because the volume of a cylinder was pi r squared h. Now, what this means is that if we cut the cylinder into 3 different sections, This cone, if it was melted down, it would fill only one of the thirds of this cone. So the volume of the cone is 1/3 pi r squared h. Okay, unfortunately they don't have any fancy things to do with this one, except you get to move this around. Okay, so that's all there is for that net. Okay, so let's go back to the lesson. And so here are some of the formulas for the surface area and also the volume formula. So for lateral surface area, we just have pi r times L. So pi r L for lateral surface area. Total surface area then is pi r squared. So pi r L is our lateral area, and then the base is here. So we have to add it together to get the total surface area. So then volume, again, is just 1/3 pi r squared h. Okay, so these are the important formulas of a cone. So I would write them down unless you still have my handout that has them on it. Okay, so next we're going to do an example. Okay, so if I have a right circular cone that has a base radius of 6 centimeters and a height of 8 centimeters, find lateral curved surface area. So for some reason your book calls it curved surface area. Most books call it the lateral surface area. Okay, so let's remember a picture is worth 1,000 words. So let's draw a quick cone. And the dotted line means it's hidden, you can't see it. Okay, so we have a height here coming down to the center here and a right angle. So it says the radius is 6. So this is 6 and the height is 8. And it says find the lateral curved surface. Well, lateral surface area, let's abbreviate lateral area, is pi r L. But wait a second, we don't know L. That's a bummer. But we have an ability to find L because this is a right triangle and we know Pythagorean theorem. So what we can do is say, oh, a squared plus b squared equals c squared. And then we have 6 squared plus 8 squared should equal c squared. Okay, so then we have 36 plus 64 equals 100. So if c equals the square root of c squared, what is the square root of 100? Okay, so c ends up being, we're going to put c is the same thing as L in this case, which ends up 10. Okay, so remember C is always the hypotenuse, and the hypotenuse is always across from the right angle. So this equals C of the Pythagorean theorem. All right, so now that we know that, we can plug it in, and if we leave it in terms of pi, that's awesome, it's easy. So pi, and then we have 6 times, and then we have L is 10. So that makes it really nice and easy, because then what we have, I'm going to make some room here. what we have is 60 pi, and our units are centimeters, so it's going to be centimeters squared. Okay, so that gives us lateral surface area, but total surface area means we have to take the lateral surface area plus the base area. So another formula for that might be total surface area equals the base area plus the lateral area. So that might be a way to remember it as well. So if we look at total surface area, our base area is pi r squared plus pi rl. We already calculated pi rl. So now we just have to do pi r squared. So pi and then radius was 6. So 6 squared plus our 60 pi. And 6 squared is 36. So we have 36 pi plus 60 pi. So our surface area then is 36 plus 60 is 96 pi centimeters squared. Okay, well, volume is much easier, so we just write volume equals 1/3 pi r squared, so the area of the base times the height. Okay, so in this case, we have volume equals 1/3 pi. We have r squared, which is 36, or 6 squared, and the height is 8. Okay, so again, we have 1/3, 6 pi, and then 6 squared is 36 times 8. Now 1/3 of 36 happens to be 12. So that makes it easy. If we reduce in the beginning, we can just do 12 times 8, which gives us 96 pi. But now we have to be careful because we're talking about volume, which is 3-dimensional. Area is 2-dimensional. So it's centimeters cubed, not centimeters squared. Centimeters cubed for volume. Volume is 3-dimensional. Think of water being poured in a glass. All right, so okay, so a quarter of a circle of a radius 12 centimeters is wrapped to form a cone such that OA coincides with OB. Ooh, well, like I said, a picture is worth 1,000 words, so let's draw what we're doing here. So this is a quarter of a circle. Okay, so we have this quarter of a circle, and it says the radius is 12 centimeters. And it's a quarter, so this happens to be a right angle. Okay, not that that makes much difference in this case. Okay, so now we're going to take this, and then this is O, A, and B. So what they're saying is when we make this into a cone, O and then AB are going to be right together. So we're going to match them up. So they get matched together. This side will match up with that side. So this will be 12 centimeters right there. So that's going to be L of our cone, but this is the radius of the original circle. All right, so we can find our mission is to find the base radius. So now we need to find this radius, which is different than the radius of the circle. Okay, so we know that lateral area equals pi RL. Okay, and we also know that this area, before we did that, so the regular area of a circle is pi r squared. But we're only doing 1/4 of the area since this is a quarter. So we're going to multiply this by 1/4 as well. All right, so since this is going to be wrapped into that cone, then this pi RL should equal this area here. So we should have pi RL. Oh, and let's change this because that's not the same as the other radius. So let's use this. Okay. So this is the radius of the circle versus the radius of the cone. So let's actually identify that. So R is the radius of the circle. And little r is the radius of the cone. Okay, so let me make some more room over here and we'll do our work. So what we have is pi r L then should equal 1/4 pi big R squared. Okay, well this is big R right here, and there's my little r that I don't know, but I do know what L is, so L is 12. So now I start substituting. So I have pi r times 12 equals 1/4 pi, and then the big R here is the radius of the circle, so that's 12 squared. Or we could write this as 12 times 12, because that's the same thing as 12 squared. Now, if I want to get R by itself, then I'm going to multiply by its multiplicative reciprocal, which will be 12 pi. So the pi's cancel and the 12's cancel. So I end up with R equals 1/4 times 12, which we know that's 3. So since our units are centimeters, our radius of the cone is 3 centimeters. And there you have it. Okay, let's try another example. Okay, so this one says find the volume of a cone with a base radius of 6 centimeters and a height of 7 centimeters. So if we draw the cone really quickly, okay, we have a height of 7 and a radius of 6. Okay, but the volume of a cone is just 1/3 pi r squared h. So they gave us h, which is 7 centimeters. They gave us r is 6 centimeters. So it's just plug it in. So 1/3 pi and then 6 squared times your 7. Okay, so 6 squared, 6 times 6 is 36. So we have 1/3 pi times 36 times 7. Okay, so 1/3 of 12, or 36 is 12. So then we have 12 times 7, which is 84. So we have 84 pi, and our units are centimeters, and its volume, so it is three-dimensional. There you go. So centimeters cubed. All right, then we might see a question like this where they ask, find the surface area and the volume of the cone below. Well, again, we have a right triangle here. This is our C. This could be A or B, and then this could be B, which is also going to be our height. So we need to find that height. So what we're going to do is we can change A squared plus B squared equals C squared by subtracting the A squared on both sides. Okay, so this gives us C, which is equal to the square root of C squared. And then we have C squared minus A squared. So we'll just put that into the square root. C squared minus A squared. Okay, so when we cancel this out, here we get B squared equals C squared minus A squared. Okay, so in case you didn't follow how I went, oops, this is B, good thing I checked. So that's how I ended up getting B, which equals the square root of B squared, which is C squared minus A squared. Okay, so now I'm trying to find B because it's the height. Okay, so let's say height equals B, which equals the square root of C squared, so 13 squared minus 5 squared. So that gives me the square root of 169 minus 25. And that happens to be the square root of 144, which many of you know that the square root of 144 is 12 squared, or 12 times 12. So H is 12. All right, so now we have everything because this is also L. So we have our height, we have L, we have the radius. So our total surface area is pi r squared plus pi rl, which will be pi times 5 squared plus pi times 5 times 13. Okay, so that gives me 25 pi, and 5 times 13, let's see, that's 65 pi. Okay, so my surface area then ends up being 25 plus 65 is 90 pi. Okay, so that's 90 pi, it's surface area, so it's centimeters. Oh, we don't have units. Oh, so if we're not given units, this is important. We write units squared. Okay, you still have to put your units there. So you write U squared or units squared, you can write it out. Okay, so now let's look at volume is 1/3 pi, and then we have r squared, which is 5 squared times the height. The height was 12, thank goodness, because that is divisible by 3. So let's divide the 3 out and make that a 4. Okay, 5 squared is 25, so we have 25 times 4 pi. And 4 quarters is $1, so we've got 100 pi, and we don't know our units, so we can write u, or we can write units like that, and then we write cubed because we're using volume. Okay? So that's how you would solve that. Okay, so let's look at this last problem. Okay, so the last problem we have is we have this prism. So this prism is filled with water. Okay, and then we're going to pour the water from this prism into this cone and fill this cone all the way to the top. All right, so first we have to have the volume of the prism, okay, which is length. Oh, this one's different because it's actually, this prism has a different base. So we're not going to do length times width times height. We're going to do base area times height. Okay, so we see that the base area is a right triangle, because even though that doesn't look like a right angle, because of the way we're looking at this, this is a symbol for a right angle. So we have 6 here, we have 9 here, because that's 9, so that's 9. So our right angle looks like this. And we have 6 and we have 9. So the area of that base for a volume of our prism is 1/2 base times height, base times the height here. So 1/2 times 6 times 9. Then we multiply by the height of the prism. So you can always tell the height of the prism because the base, which is here and here. So it's like it's stretched up. So that's what makes it the height. So the height also has rectangular sides. So sometimes you might be thinking you're looking at a rectangular prism when actually you are looking at the side of the prism, because the sides of prisms are always rectangles. Okay, so the height happens to be 10, so that's going to make it nice and easy for calculating. So 1/2 of 6, so if we take a 2 out of 6, we have 3. 3 times 9 is 27 times 10, which gives us 270. And do we have units? No, we do not have units, so this is volume, so units cubed. All right, so now what we're going to do is look at this. So the volume of the cylinder is 1/3 pi. We don't know what r squared is, but we do know the height is 15. Okay, so we can take this out and take a 3 out of the 15. So this is going to be 5 pi r squared. Now the volume of the cylinder should equal the volume of the prism, because this is filled with water and we're going to pull the whole thing into here. So now we can set this equal to that. And somewhere I have lost an important piece. You may have noticed what piece I lost. But because I am, let's see, oh wait, I did not miss an important piece. Because we are not dealing with a circle, we are dealing with a prism. Now we're dealing with a circle. As soon as we start dealing with circles, that's where this wonderful pi shows up. So now we actually have to, when we're dealing with that, we actually have to calculate what pi is. Well, let's do it the old-fashioned way. Okay, So this is pi approximates to 3.14. Okay, so 5 times pi, we could just multiply 5 here. So we have 5 times 4 is 20, carry a 2. 5 times 1 is 5, plus 2 is 7. And then 5 times 3 is 15. And we move the decimal 2 places to right here. Okay, so that's what this amounts to. So this equals 15.70 r squared, and then that's going to equal this 270. So now we're going to have to divide by 15.70. Okay, so let's try it. Okay, so this is going to be a little rough. So we have 15.70. Actually, before we did that, let's do this the easier way. Okay. Well, we can just continue. The easier way that I should have done this is I should have just divided 270 by 5 and then divided by 3.14. Okay, so, but I started this way, so let's just continue. Okay, and I have to put 2 zeros here, so I move this over 2 spots. So my new decimal's here. Okay, so now I can kind of guess how many 15 or 1600s are in 2700. Let's see. So how many of these are in 2700? That would be 1. So we put 1570 right here. So right here we are just doing 1 times 1570. Okay, when I subtract, I borrow 1 from here. So 10 minus 7 is 3. Then I have 1 and 1. Since this is less than that, we did okay. So then we drop a 0 down. So now we have to ask how many 1570s are in 11,000. So that gets a little harder. So we might want to take a 0 off of each one. So how many 160s are in 1200? Well, we know how many 200s are in 1200. There's about 6. So maybe we could go 7. So let's try 7. So our guess is 7 times 1570. So 7 times 0 is 0. 7 times 7 is 9. 49. And then 7 times 5 is 35 plus 4 is 9. So we have 39. And then 7 times 1 is 7 plus 3 is 10. So when we subtract, we get 0. We borrow, we get 1. We borrow again. We get 3. So we did a good guess. Wow, we got lucky, huh? Well, actually, that wasn't luck. We were strategic. That's what we do. All right, so we still haven't finished, so we should probably drop another 0 down. And this is very close to 2. Okay, so I think it's only going to miss it by by 40. So I think what we're going to see is something like 19 here. So so we could say 1 here because we know it's going to miss it just by a bit if we doubled that. So we have 3, 5, 1. So see how we just missed? So that means that this next number is probably going to be a 9. So we have a radius squared, and that's going to be a joy because that's a radius squared, which is 17.19-ish. You know, it approximates. So now if we're going to ballpark this number is very close to 16. What's the square root of 16? It's about 4. Okay, so then 25 is the next square, perfect square. So this is pretty close to 16 though. That's pretty far from 25. So I'm going to say this, just guessing, that this is probably about 4.1 or 2. So let's go with 4.1 units. And let's try this out with a real calculator and see how we did. Okay. All right, so from here we had 5 pi. So 5 times pi, there you go, pi, is 15.7079. Okay, well, that's because pi is, so it's 15.70, let's see, here we go. So that's what 5 pi is. Well, we made an approximation, so we approximated to 15.70. So we've already added a little error in there. Okay, so now we're going to divide 270 by this number. Let's see, trying to get the light just right. There we go. And hit enter. So now we have 17.188, which is about 17.19, what I said it was probably going to be. So now we need to take the square root. So we're going to take a square root and choose that and see what we get. And I said it was about 4.1, 4.2, and with what numbers I was using, it'd be closer to 4.1, but when you actually use a graphing calculator, it's 4.15 if we approximate to that. So we did a really good job with the old-fashioned math there, you know. Okay, so that is it with the cones. Hope that was a nice refresher for long division and a little logic and strategy. Oops, so this is approximates to that. So I should change this over really quickly. So R then approximates to 4.1 units. So that's what we were trying to find. There we go. Now it's all better. Sorry, R squared was 17.19. R is 4.1 units, or approximately. All right, you have a wonderful day. Bye-bye.